So this is a joint work with Irina Ceausescu. It's a technical paper about expected utility operators, where we consider possibilistic risk instead of probabilistic risk in a saving decision or optimizing saving. So I'll first say a few words about the motivation, then about this setup and how we transform the problem from probabilistic to possibilistic one. And then I shortly go through some moments of the utility function and particularly the risk preferences which can be which are included in the utility functions. Then we have solved the approximate calculation formulas, and I present one for general type, and then I conclude the paper. So we are dealing in this paper only with two periods. So we have period 0 and period 1. And a consumer has to deal with the possible loss expected or possible in the second period, period 1. And he is to make a decision how much he is going to save from today's first period's wealth or income. So he wants to maximize the total utility. And the amount he saves in the optimal case is called optimal saving. The problem has been discussed in many papers, and starting by Therese and Modigliani in 1972 already. So precautionary saving is the amount saved when we add a risk to the second period. So we can, it's analogous with the insurance problem, and we can find analogies to portfolio optimization. But we come back to that in the end of the presentation. So there's an extensive literature about this kind of saving problem, and all of these consider two models. The first one is deterministic, where there is no risk. Then they add risk to the second period and compare these two models. And how this risk adding then causes growth or decrease in this optimal saving. So this is the problem. In a probabilistic case, we can write the total utility function like in the below. So it's, there are two utility functions in this total utility function, U and V. U is for the first period, wealth minus the saving, which is saved then for the second period, which increases by the interest, and then there is a random variable of the second period wealth or income. And in our case, we transform this to possibilistic optimization problem. So basically, what changes in the utility function is just that we consider the future, the second period income and wealth as a fuzzy variable. So we are using expected utility operator T instead of M here, which an operator finding the expected value, whether it's a mean or how it's wanted to be calculated. And this total second period part of the equation is a generalized possibilistic expected utility. This is based on Irina Georgescu's model from 2012, where all the other published possibilistic models get inside this generalized version. So just shortly about the risk preferences. So risk aversion, Arrow-Pratt index for this is just the second derivative of the utility function, and its ratio to the first derivative. And the higher the risk aversion, the lower is the actor's willingness to take risk to achieve some uncertain payoff. Then prudence is just a higher moment of this, using higher moments of these utility functions. So it's the ratio of the third derivative and second derivative. And in practice, it measures the intensity of the precautionary motive, while risk aversion measures the intensity of desire for insurance. And we are not using this in this current paper, temperance, but it's using still higher moments, so it's the fourth derivative a ratio to the third derivative of the utility function. And it's shown to be important when the background risks are skewed. So the distribution is skewed to some of the direction. So we have just shown and proved in the paper how we get an optimal solution to this T model of optimal saving, how we call this model. So it looks a bit ugly model, ugly formula, but you can find there these first derivatives, third and fourth derivatives. So likely also this and second derivative. So likely also this temperance could be relevant, but it's left for as an open problem. So what we found here was that this prudence, which we call T-Prudence in this possibilistic case, is meaningful. And when we find prudence in this possibilistic case, it means that the optimal saving increases. So in equality where the third derivative of the utility function for the second period is positive, it's already both necessary and sufficient condition for this optimal saving to increase for the second period when risk is added. Well, as a conclusion, just we discussed about these utility functions and risk preferences represented by them. We applied generalized expected utility and solved some approximate calculations formulas for this. I just presented one, but in the paper we have calculated them for different types of utility functions. And the key finding was that when prudence increases, it increases the optimal saving as well. So about the future work, maybe relevant here could be either applying our approach to different kind of investment problems, but maybe even more interesting, for example, I heard that Golan and et al. Had published some paper in this insurance case with real options. So I just wonder whether such could be applied in this kind of insurance problem. Okay, that's it. Thank you.